All right, ladies and gentlemen, welcome to the notes for Chapter 2, Section 5, Part 1. Graphing Rational Functions and Transformations is the title of the section in your book, and we are talking specifically in this set of notes about reciprocal functions. Now, in theory, this is a review of work that we did back in Chapter 1 when we first discussed parent functions, because we should remember that we have already graphed the parent function of all reciprocal functions, that is y equals 1 over x. And remember that y equals 1 over x has a horizontal asymptote of y equals 0, which is the x-axis, and a vertical asymptote at x equals 0, which is the y-axis. And that it looks like this. It comes in along that vertical axis, it passes through the point 1, 1, and then it goes out along the x-axis. And it does the same thing in quadrant 3. It comes in along the axis, passes through the point 1, negative, or negative 1, negative 1, and then it exits down there along that axis. And really my picture could be better. Let's see if I can get a little better curve there. Anyway, we should remember this. This is the parent function for all reciprocal functions. And if we've got that function in the form f of x equals a over x minus h plus k, h is our horizontal shift, and k is the vertical shift. We should also remember that the a value controls the vertical stretch, and we should remember that if it is negative, then we're reflecting. Okay, that should all be information that is already in our toolbox, as it were, that we already know how to do. So, when we graph a reciprocal function, we need to make sure that it is in general form. When I say general form, I'm referring to y equals a over x minus h plus k. If it is not in that format, we may need to use long division to put it into that format. Then we are going to determine the vertical and horizontal asymptotes, which would be the lines x equals h and y equals k, and we will graph them both. Then we will find the y-intercept, that is, we will set x equal to 0. That'll just give us a point. We may or may not use it. Finally, we will make a table, and we will find 3 points on each side of the vertical asymptote. I suggest that you use points that are half a unit, 1 unit, and 2 units away on each side. Then we draw the final graph. So for instance, here on example 1, we should look at this graph and we should go, okay, we have an a value of negative 3. We have an h value, there is no h, of 0. And we have a k value of 1. So what this tells us is the a value tells us that the graph is reflected through the x-axis. That's because a is negative. It has a vertical stretch factor of 3. It is not shifted left or right. That would be because h equals 0, which means our vertical asymptote is x equals 0. Okay, and it is shifted up 1 unit. This is what we did back in the very first chapter. So what we'll do is we'll start by jotting a pair of axes, such as this one. That's going to be our X and Y axis. And we're going to mark those off. Just to 5 should be fine. Try to be as neat in your spacing as you can. So it might be good to go to 6 on that vertical if we can. Just because I already know what's going to happen with this bad boy here. So let's stretch that out just a little bit. Okay. Then we should draw our asymptotes. So our vertical asymptote, which we'll draw with red dotted lines, is the y-axis. So there's nothing fancy there. It's the axis itself, meaning that the line would be on top of the y-axis. And the horizontal asymptote is y equals 1. So then we're going to create a table of values. We need 3 points to the left of our vertical asymptote. I would suggest that you use -1/2, -1, and -2. And 3 points to the right of the vertical asymptote, which I would suggest you use 1/2, 1, and 2. Again, that gives you values that are 1/2 a unit out on each side, 1 unit out on each side, and 2 units out on each side. We're going to take those x values and plug them in to this equation for x to solve for y. And you can use your calculator to do that. -3 divided by -1/2 is +6, plus 1 is 7. -3 divided by -1 is +3, plus 1 is 4. Plug in -2, -3/2 divided by -2 is 3/2, plus 1 is 5/2, or 2.5. So if we graph those points, unfortunately 7 is a little bit off the top, so we're going to have to guesstimate, be about right there. -1, 4. -2, 2.5. Would be about right there. So as you can see, the shape that we're getting is we're going to come in, pass through those points, and pass back out along the top. Okay, we do the same thing for the other side. 1/2 goes in. -3 divided by 1/2 is -6, plus 1 is -5. 1 goes in. -3 divided by 1 is -3, plus 1 is -2. 2 goes in, would be -3/2, plus 1, which would be -1/2. Graph those points. So 1/2, -5. 1, -2. And 2, -1/2. So again, we can see that we're coming in along that axis, passing through those points, and exiting along our horizontal asymptote as such. And we've done this before, guys. We did this back in chapter 1, so this lesson ought to be a relatively simple lesson for us. Okay, on to example 2. This time it says sketch the graph and identify the domain and the range. So we'll talk about domain and range at the end. We're still going to start off the exact same way we did before. We need to identify A, which is 1. Which means this graph is actually going to be easier to graph than the last one. H is equal to -1, and K is equal to -2. Remember that H always has the opposite sign of what's in the equation. Okay, so this tells us our shift. We've got a vertical asymptote of x equals -1. We've got a horizontal asymptote of y equals -2. And that's x equals h and y equals k. We're going to start off with just a pair of axes. They don't need to be anything special. And we're going to be making a table of values. Again, I'm suggesting that you pick points, 3 points to the left and 3 points to the right of -1, which would be -3/2, -2, and -3 on the left side, -1/2, 0, and 1 on the right side. We're going to plug those values in before we draw the asymptotes just to make sure that we get the scale right on our graph. So plug in negative 3 halves. That's 1 divided by negative 3 halves plus 1, which would be 1 divided by negative 1 half, which would be 1 times negative 2, or negative 2. Minus 2 would be negative 4. Plug in negative 2. We get negative 1 half minus 2, which would be negative 5 halves. Plug in negative 3. We would have, oh, I lied, that's not true. Let's try that again. When we plug in negative 2, we would have 1 over negative 1, which would be negative 1, minus 2 would be negative 3. Plug in negative 3, we have 1 over negative 2, which would be negative 1 half, minus 2 would be negative 5 halves. So I jumped the gun a little bit on my... Okay, graph those 3 points. Well, let's look at those numbers. Those numbers are pretty nice there. Looks like we'll be able to go positive 5, negative 5 on each side, and we should be good on our graph. 2, 3, 4, 5. Again, we want to be neat in our spacing so that our graph can stay as nice as it can. We'll go ahead and we'll draw in our axes, or our asymptotes. We have a vertical asymptote at x equals negative 1. And we have a horizontal asymptote at y equals negative 2. Graph the points that we've already come up with here. We have negative 3 halves, negative 4, negative 2, negative 3, and negative 3, negative 2.5. So again, we can see the shape coming in along the axis, and we're exiting, or we're in along the asymptote and exiting along the asymptote. Plug in negative 1 half. 1 over negative 1 half plus 1 would be 1 over 1 half, which would be 2. Minus 2 would be 0. We kind of want that to be in black, so we'll fix that real quick. Plug in 0, that's 1 over 1, which is 1. Minus 2 would be negative 1. Plug in 1, that is 1 over 2, 1 half. Minus 2 would be negative 1 and a half, or negative 3 halves. Graph those 3 points. Negative 1 half, 0. I want this to be in blue. Negative 1 half, 0. 0, negative 1. And 1, negative 3 halves. Again, it comes in along that axis, or that asymptote, passes through those 3 points, and exits along that asymptote. Now, let's talk domain and range. Remember, the domain is your x values that are allowed for this function. So there's only one x value that does not exist for this function, and that is the location of the vertical asymptote. That is at h. So your domain for any of these functions is always going to be negative infinity to h and h to infinity. So for this particular example, that would be negative infinity to negative 1 and negative 1 to infinity. Your range, you're going to look at the y values. There's only one y value that does not exist, and that is the horizontal asymptote of negative 2. So your range for every single one of these problems will be from negative infinity to k, and from k to infinity. So for this particular example, that would be negative infinity to negative 2, and negative 2 to positive infinity. So that's how you do domain and range for a reciprocal function. The domain is broken at h. The range is broken at k. Otherwise, it has all real numbers. Okay, example 3 does not require us to graph. Example 3 requires us to identify the transformations. So that requires us to identify a, h, and k. So the first thing is, this equation is not technically written in standard form. We need to move this negative up into the numerator, and we need to move the 5 to the other side. These are the same function. One is written in standard notation, and one is not. So we need it in standard notation. Why? Because that tells us that a is negative 1, h is negative 1, and k is 5. We need that because that's what we use to describe the transformations. The a value, being -1, tells us that the function, or the graph, is reflected across the x-axis because a is negative. There is no vertical stretch. That is because the absolute value of a is 1, so there's no stretch. If it were not 1, there would either be a stretch or a compression, depending on the value. The h value of -1 tells us that the graph is shifted left 1 unit because h is -1. And the k value of 5 tells us that the graph is shifted up 5 units because k is +5. Again, those two things really should all be review, and we should be able to move on without too much of an issue. Okay, example 4 is the first really new thing, and it's really not anything that we shouldn't know how to do, because in theory, we'd have all the skills in place already to do this. We've already spent an extensive amount of time talking about the skills required to take g of x and write it in standard form, because right now it is not written in standard form. Standard form would be a over x minus h plus k. It is not written that way. So, what we need to do is we need to carry out long division on that polynomial fraction. We need to divide x plus 4 by x minus 3. When we do that, we ask ourselves, what do we need to do to x to turn it into x? Well, we don't need to do anything, so we multiply by 1. 1 times x is x, 1 times -3 is -3. Draw the line, change both signs, add down. We have a remainder of 7. What that means is that g of x can be written as 7 over x minus 3 plus 1. That is in standard form. Again, the reason we need to do that is so that we can identify our a, our h, and our k. So that we can sketch our graph. Now this graph is going to require a bit more because of that vertical stretch of 7. We're going to need a slightly larger graph than we've had before. We've got a shift to the right of 3 units and a shift up of 1 unit. So what I'm going to do is I'm going to mark this off by 2's. So 2, 4, 6, 8, 10, 12. And I'm going to show that by simply stating that next to my label on the x-axis. 2, 4, 6, 8, 10, 12. I'm going to do the same thing on the y-axis by 2's. And I may not need all of these marks, but I just want to make sure that I've got plenty of room on my axis. Now, what we're going to do is we're going to start by drawing our axes, our asymptotes rather. We have a vertical asymptote at x equals 3. That would be halfway between 2 and 4. Again, this is the line x equals h. So that'd be x equals 3 because x 3 is the h value. Then we have the line k equals 1, which is going to be a little bit tough to put on here because it's halfway between 0 and 2. That would be right there. Remember that this is the line y equals 1 because we use y equals k for our horizontal axis. Now we need a table of values. So when we go to make our table of values, once again, I'm going to remind you that we're supposed to be using 3 points on each side of our vertical asymptote. So our vertical asymptote is at 3. That means I would be using 2.5, which would be 5 halves, 2 and 1 on the left side, 3.5 or 7 halves, 4 and 5 on the right side. We're going to plug those values into this function and see what comes out. So when we put in 5 halves for x, we have 5 halves minus 3, that would be negative 1 half. 7 divided by negative 1 half would be negative 14, plus 1 would be negative 13. Plug in 2. 2 minus 3 is negative 1, which would make this negative 7, plus 1 is negative 6. Plug in 1, that would be negative 7 halves, plus 1 would be negative 5 halves, or negative 2.5. We can go ahead and we can graph those points and see that piece. We have 5 halves, which would be about here, negative 13. Let's see, 2, 4, 6, 8, 10, 12 would be right here. Okay. 2, negative 6 would be right here. And then 1, negative 2.5 would be about right here. So again, you can see that same sort of shape evolving here. We're going to come in, we're going to cross through, and we're going to exit along the axis. Okay? Going to exit along the axis. Okay? Then for the other side there, 7 halves goes into this function. 7 halves minus 3 would be 1 half. So 7 divided by 1 half would be 14, plus 1 would be 15. 4 goes in. 4 minus 3 is 1, so that's 7 over 1, which is 7, plus 1 is 8. 5 goes in. 5 minus 3 is 2, so that's 7 halves plus 1, which would be 9 halves, or 4.5. And we graph those 3 points. Again, we should have a pretty good idea what that's going to look like. 7 halves would be 3.5. That's about right here. And then we'd be up at 15. About right here. Then we've got 4, 8. Should be about right here. And then we've got 5, 4.5, which would be about right here. So again, we can see that same basic shape. We're coming in and we're exiting along the axis. Nice and simple stuff. Okay, example 5 goes the opposite direction. It asks us to write equations for the given graphs. So the big part here is we need to identify the x or the h and the k values. So what we need to do is we need to go into this graph. We need to ask ourselves, what is it approaching? Well, if we look closely, we'll see that this graph is approaching negative 3 on each side for the horizontal axis, and it is approaching positive 1 for our vertical axis. Okay? So what that tells us is that tells us our h and our k value. We've got y equals negative 3 and x equals positive 1, which means k is negative 3 and h is 1. As for the a value, you'll notice that normally the parent function would pass through right here, 1 unit up and right from that crossing point of those two asymptotes. But it doesn't. It crosses 2 units above. See how that is 2 units instead of 1? That means that a is 2. So this function, we'll call it f of x, would be 2 over x minus 1, which is h, minus 3, which is k. Okay, same idea over here. We're just going to set up a divider here real quick. Make sure we keep the work separate. Okay. So we go in here and we say to ourselves, where are our asymptotes? We've got a pretty clear horizontal asymptote at positive 1, and we have a vertical asymptote at negative 2. Okay, so we have x equals negative 2, which tells us h is negative 2. And we have y equals positive 1, which tells us k is 1. Now normally, our parent function would pass through one unit right and up from the intersection of those asymptotes, but it doesn't. It goes negative 1 right there. So that tells us that our a value is negative 1. So this one, we'll call it g of x, would be negative 1 over x minus h would be x plus 2 plus k. Done. That does it for this section of notes. Thank you very much for your time and attention.